Oh, well, hello there. Welcome to the last video for pre-calculus, Law of Cosines. So we did Law of Sines, we're learning about solving triangles, and this is the last tool in your toolbox to be able to solve triangles, any triangle, not just solving right triangles, any triangle. Some of those tools that we have, by the way, just to recap, is um, we would have, if it's a right triangle, we would have all sorts of tools, Pythagorean theorem, trig functions. But what happens is, to solve non-right triangles, we were looking at law of sines in the last video, and law of sines was the one where you put sine of an angle over its opposite side, and you can set that equal to any other angle over its opposite side. This enabled us to solve situations where we're given, like in this example, this is the last section, when we're given two angles and a side, we can solve because whenever you're given two angles, you can find the third angle. So you have all three angles. Um, and then you can use the angle opposite the side that's given, the angle on the side opposite, whatever side's given, out of the side's given. So you can find the third side always because you have two. So whatever side's given, you'll have the angle opposite of that. So whenever two angles are given, no matter what the case is, you can always solve those kind of triangles. We did look at the ambiguous case, though, too, when two sides and one angle is given. So the problem with this is we're only given one angle, but we are given the side opposite that angle in this case. And this is an ambiguous case, so sometimes this makes one triangle, which is the normal, what you'd probably prefer, but then sometimes it makes two triangles and sometimes it doesn't make any triangles. Well, when it comes to solving triangles, there is they give us three pieces of information and we're asked to find the other three other pieces of information. So what can they give us? Well, they could give us, out of the six pieces of information, three angles, three sides. If they ever give you three angles, that's completely unsolvable because there are an infinite number of triangles that are all similar triangles with the exact same angles but different size lengths. You could just imagine like a triangle, like a 45, 45, 90 triangle, and you can make it big, you can make it small, and they all have the same angle measure, right? So you'll never be given three angles and asked to solve. If you are, you'll say, can't solve. You always have to be given at least one side. If they give you two angles and one side, then law of sines, we did those, okay? If they give you two sides and one angle. Now, what we had done before, so there's two different ways they can give you two sides and one angle, okay? So what the case that we were looking at over here was giving us two sides and an angle that's not between them. So we weren't given B, okay? We were given an angle not between them. So we could be given two sides and the angle between them. And as you can, if you look at this example here, and just imagine that this was the angle given instead of these two. Well, you can't use law of sines on that because if this is the angle given and we don't know the side opposite, and this is the two sides given and we don't know the angles opposite, we need a pair. We need a pair of an angle and a side to use law of sines. Okay, so then this case right here, like this case here is obviously going to work with, but I'm saying if we move this 30 up here, that case would not work. That's a side angle side scenario. Okay, this is a side angle scenario. Side angle side, we can't use law of sines. The other thing they can give us that we can't use law of sines is if they give us all three sides. If they give us all three sides and no angles, that is a solvable triangle that we can do, but not with law of sines. And that's where we find ourselves with law of cosines. Law of cosine. So I'm going to go through a little bit here on how to get how a law of cosine is. I don't know if you want to call it a proof or just how it comes about or how it works. And then we're going to use it to solve some triangles. The two situations are when you have two sides and an angle between them, and when you have three sides given. Those are the two scenarios. So that would cover all the possibilities, by the way. Angle, angle, angle never happens. Side, 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 law of cosines. Side, angle, side is law of cosines. Side, side, angle of law of sines. And then angle, angle, side, or angle, side, angle are both law of. Whenever you're given two angles, doesn't matter if the sides in between. You can always find the third and use law of sines. So hopefully that was clear. So we're going to take a triangle. This is just a generic triangle. And I'm going to put it on the coordinate plane just to make the distances, just to make calculating a little bit easier here. So if we put one of the corners here and put one of the sides along the x-axis, the distance, so this corner here would be considered 0, 0, because that's at the origin. The distance along the x here, this corner here, or I should say vertex, not corner, is b, the length of this side b. This would put this point here, x value b, whatever that length is, comma 0. That's the ordered pair. The triangle will have a certain height, and remember height is the perpendicular to the base. In this case, this is our base. So the triangle's height would go from wherever it happens to be, but straight down perpendicular to the base. So this point here, b, would be the distance for the x value would be this distance. The y value would be this distance here. You can find what this distance here is right here by, let me type this up, because cosine is adjacent, right? So I'm looking for this distance here, and cosine of and the angle A, whatever this angle is over here, I'm labeling this A, is equal to, escape out of the cosine, is equal to the opposite, no, sorry, cosine, early, is adjacent, which would be what I'm looking for, this distance right here. So I'm going to just put adjacent over the hypotenuse, which is C in this case. Okay, so because it's not labeled, I wrote ADG to indicate this distance here. Okay, well this would actually, maybe what I could do here, instead of saying adjacent, I could call that X, my X value, okay, because it's the X value. So that means the X value, because if you look at that algebra, I can multiply both sides by C, so C times, get a real times here, times cosine of A is equal to X. The X value is C times cosine of A. So that's how I got that right there. That's what I was trying to show you. Okay, and I did that using this is the right triangle, by the way. Ooh, important part. So then I could use I could just use the trig function straight up. Okay, adjacent. This is what I'm looking for, over hypotenuse, and adjacent is what I'm looking for. So cosine of this angle is equal to adjacent, this distance here, from here to here, over this distance, multiply C, this distance to both sides, and this distance down here is whatever cosine of A is times the hypotenuse, will be this distance here. That gives me the X value for B. Same with the Y value. You can change it to sine and change this to Y, and you'll have the same thing, opposite over hypotenuse. And then multiply C by both sides. So this ordered pair up here, B, is C, whatever this hypotenuse is of the right triangle, there's no hypotenuse for the larger triangle because it's not a right angle, or not a right triangle, but we're calling C the hypotenuse. So this ordered pair is this side C times cosine of A, and then comma c times sine of a. Okay, is this ordered pair? The point that this is at, the distance that is from the origin here, and then this distance here for the y value. Okay, so once we know what b is and we know what c is, okay, so we know these ordered pairs, we can actually use the distance formula. Well, we don't actually know numerical values, but we have variables values of them. We can actually use the distance formula on any of these 2 points to find the distance of any of the other sides. So if I want to write the length of A in terms of C, side C, I can actually do that. And the distance formula is actually kind of like the Pythagorean theorem. It is a Pythagorean theorem. So I can take, a squared, because now you remember this is a right triangle, okay? A squared is equal to the difference between B and C, the x value. Okay, so it's still a Pythagorean theorem. The distance formula is given from the Pythagorean theorem. It's gotten from the Pythagorean theorem. But we're going to take the difference between x value of this point, B, and the x value of this point, of angle B, vertex B, and the difference between these 2 ordered pairs. So the difference between C times cosine A and B, which would be C cosine A minus B, square that because of Pythagorean, C sine A minus 0, okay? So, because that's 0 if we put this vertex over here, okay? So, let's just do the algebra here. This is if you have to FOIL situation here. We have C cosine A minus B times itself. Over here we have C times sine of A minus 0, which is just, minus 0 goes away. So you can actually, you have to do FOIL, like I said. And in this one, you can, because there's no plus or minus inside, you can just take each of these squared, each part squared. So first, cosine times cosine A times cosine A would be C times cosine A. C times cosine A would be 2C's, C squared times cosine squared A. Then I have a negative B, so this is first, and then outer, so then it would be negative B times C cosine A, and then inner, negative B times C cosine A, and then last would be B, negative B times negative B, which is positive B squared, and then this C squared and sine squared. So, we have 2 of the same terms here, BC cosine A, which becomes 2BC cosine A. Okay. Not done yet, because I'm going to do some rearranging, because I notice something going on here with a sine squared and a cosine squared. So I'm going to group those together. Okay, so I put the sine squared and the cosine squared next to each other. I just rearranged here. I move the negative 2BC cosine A to the end, the B squared to right in front of it, and then I'm putting C squared sine C squared plus C squared cosine squared together. I'm going to pull C squared out, and I have sine squared plus cosine squared, which we know is 1. So this simplifies to A squared is equal to B squared plus C squared minus 2BC times cosine A. And why in the world did I just do all that? Well, let me just go back to A squared. I could find A, so what this allows me to do is I'm finding A, okay, so A squared plus equals B squared plus C squared minus 2BC cosine A. So that requires me to know B and C, okay, also A, angle A. So I know the side, angle, and side, and I can find the opposite side from that. But also, not just that, Okay, see how like, but just so A, side A, angle A, right? So I have angle A and the sides next to angle A, and I can find side A, which was the scenario, one of the scenarios I said, side, angle, side. But not just that, just to say what I was going to say a second ago, I could also find angle A if I'm given all three sides, because I could fill in A, B, and C, and B and C here, and then the only thing unknown is angle A. So all this here, if it was confusing and you didn't quite follow it, was just to show you that this actually works, this law of cosines. And so there's actually three of them, just like law of sines. I could have done all of this for each side. I chose to focus on A, but I could have done it for B. I could have done it for C. But ultimately, how it looks is whatever side is by itself on the equal side, that's the angle. The angle is the see how the little a is here, big A is over here. The side and the angle that are opposite each other go on either end of this. And the other two sides go in the center here. Okay, so it's a side, an angle opposite, and the other two sides. So this is a more complicated law than sines. The law of sines is a little bit more simple. But it does enable us to find things that law of sines does not allow us to find, or doesn't give us the power to find. Okay, and this is what I was going over. Law of sines will be useful when we're given side, angle, side, or side, side, side. And it is kind of helpful to be able to look at a problem and say, oh, that's a side, side, side. If I know that's a side, side, side problem, well, then I can be prepared to use the law of cosines. Or if I know it's a side, angle, side, I can be prepared to use the law of cosines. All right, so solve the triangle with sides A equal 3, B equal to 5, and C equal to 7. Okay, so there is something here that's very important. Please note that you should always find the largest angle first. Okay, the largest angle first. So we have three sides, which will have three angles. When you're using law of cosines, I should find angle C first, because C will be the largest angle given that's across from the largest side. Longest side matches up with largest angle. Smallest side, smallest angle. Okay, so I'm going to solve this for C. I have three sides. Here's a sketch. Just, it's a sketch. I don't know exactly how it looks. So this could be off. But I have my three sides. I'm going to plug them into, and I'm trying to find C. So I'm going to use the formula where C is, the angle C is used. So that puts side C by itself on this side, and then A and B's are inside. Okay, so I'm going to plug in my sides for A, B, and C. And I'm going to solve this for angle C. 49, 9, 25, 30. Should get 34. Do not do 34 minus 30. Cannot do that. People will do that. I can see it now. This cosine C makes this a variable where you can't combine like terms. Excuse me. So I actually got to subtract 34 from both sides. Get a 15. Now I'm going to divide both sides by negative 30, and I get a negative 1/2. Cosine C is equal to negative 1/2. I'm going to do cosine inverse of negative 1/2. And so, if you, let me just do this because it's the first time in this notes that I'm doing a cosine inverse. As a recap, so cosine inverse second, cosine is cosine inverse, negative 1/2 is 20 degrees, and this is in, just make sure you're in degrees. We're doing our angles in degrees for solving triangles. So 20 degrees exact, no approximately. How nice, okay? So we now know that C is 20 degrees. Okay, to find B, we can now use law of sines because we found C. So we're going to find B, and here's why it was very helpful to find the largest angle first. 120, well, let me get to it in a minute. cosine isn't going to have the same issue that inverse sine had. Just keep in mind that sine had the issue, and I'm going to maybe get to this a little bit more in a second. Sine had the issue where you did the inverse, you had to think of two angles, both the one in the first and in the second. Cosine, remember, cosine is negative in the second and positive in the first. Okay, so cosine doesn't have that same issue because the problem with sine is it's positive in first and second. So it's going through every value between 0 and 90. 0 and 180. It's going through every value twice. Let me just do a graph here real quick. Sorry. I don't think I'm being very clear. Zoom 7. It's a little bit of a tangent that I'm on anyway. Tangent. So in my window, I'm going to go from 0 to 180. Remember, we're not concerned about things anything greater than 180 because you can't have anything greater than 180 in a triangle. This is sine. So sine will go through every value between 180 and so between 180 and this is just a window here. See how it's going? I'm just looking at the top of this window as a straight edge. It's going through every value twice between 0 and 180. It's going through every value twice. So if I get sine of an angle is equal to something, I don't know if the angle is a first quadrant or a second quadrant angle. Now if I change this to cosine, I'm not going to have that problem because you see how every single value between 1 and 0 and 180 is unique. So if I get a value up here in the positive, what's the angle? Well, it's going to be whatever's down here. Okay, if I get a negative like I did here, down here, negative 1/2, what's the angle? It's going to be 120, wherever 120 is here. Okay, so I don't have to do the same, I don't have to be concerned like I was with sine inverse. With cosine inverse, I don't have to be concerned like I was with sine inverse. Okay. So all that to say, I did cosine inverse, and I don't have to go through the same process that I went through, the whole long process that I went through with finding two triangles, which is good, because that's already enough of a pain on one type of triangle, which is side-side angle. It's nice that I don't have to do it for side-side-side. Once I find one angle, then I can use law of sines to find the other angles. And even if it's approximated, even if C was approximated, because this is a lot longer of a process, it's okay to use an approximated value. Just make sure you use answer on your calculator. Use the answer button, because this is a lot more work than law of sines. So I'm going to match C up with B, and I'm going to go least to greatest. Sorry, greatest to least. So I already found the longest. Then I'm going to go the second. I'm going to stop with the shortest side. Okay, so I'm finding B. That's opposite 5. So 120 is opposite 7. Cross multiply, divide by 7, and then what I have here is 5 root 3 to do sine inverse. So here is what I was trying to emphasize earlier. I'm doing this on my calculator to get 38.2. All right, so if I already know that C is 120, so this is a sine inverse now, I don't have to worry about there being two triangles because there's not enough room for a 180 minus whatever this gives me, right? There's not enough room for a 141. There's not. This is way more than 180, right? So there's no chance that sine inverse has the larger of the two solutions is the solution in this case. So you don't have to do two triangles or anything, as long as you do this is why you need to do the largest angle first, get it out of the way, so that there's no question whether or not the sine inverse that you get, there's no question that the larger angle is a part of the triangle. Okay, hope that makes sense. if I had done the smallest angle first, which you can just find the smallest angle now by taking 180 minus the 2. See, if I had done law of cosines on the smallest angle, which you could do, I mean, it's not like you can't do that. Well, now I have 21.8, and then and that's the only angle I know. And if I do 180 minus 120.8, it's feasible that 158.2 is also a solution. So, well, no, actually, that wouldn't be feasible because the law of cosines would only give you one answer. But it's when you go to find the second answer that you wouldn't. So I'd have 21.8, okay, and then I'd find 38.2, okay. Well, now I'm not sure if 38.2 is the solution or 141.8 is the solution, because 141.8 and 21.8 both are less than 180. But by finding the largest angle first, I eliminate the larger option for sine of B, sine inverse. So for angle B, just find the largest angle first, and it'll be easier, is my point. You don't have two triangles. You won't have two triangles with side, side, side. There's not two options. If you're given three side lengths, it only makes one type of triangle. Okay? There's only one side kind of triangle it can make. It could be different angle, like you can rotate it, but you can't make a different type of triangle. Okay, so hopefully that makes sense. Of course, you can always ask me if you have questions. So the other situation is solve the triangle if A is 3, B is 7, and angle C is 37. This is a situation where the angles between the two sides, because remember, sides have to be opposite, the letters have to be opposite each other. And so this is another situation where you can't use law of sines because you can't match up opposite stuff because we don't know we don't have a pair. So C is what we're looking for here. We have angle C, we can plug in that, and we have the other two sides we can plug in, and we can evaluate. Okay, this won't have the same issue that example 1 had because, so that whole always go largest to smallest is a side, side, side only situation. Because, so I plugged it in, get 49.9, negative 42. Again, be careful. Something about people just want to take 58 minus 42 and then multiply that by cosine of 37. I'm not sure why. I've seen a lot of students do that in the past. That's just something I've seen a lot. It's just like instinctively they want to do this, but there's this times here that's more this order of operations and everything. This here goes to 33.5, and then you can get C squared is equal to 24.5. Take the square root of that, 4.95. Now, you don't have to worry about the negative when you take the square root because distances can't be negative. Okay. And this is, since you're finding a side, you're not doing sine inverse or cosine inverse, so you don't have to worry about two angles at all. So now that I have that side, even though it's approximated, go ahead and use law of cosines, although I should have made this approximated right here, because as soon as you plug in something that's approximated, you should make the equal sign approximated. So now I have 37 and the angle side I just found. I can use law of sines to find, I'm going to find angle A. I'm going to find let's see here. Why did I find angle A? Yes, when I'm using law of cosines, I want to find the largest angle first. When I'm using law of sines, I want to find the smallest angle. Because if I'm finding the smallest angle with, this is really confusing. I'm sorry, you might have to watch this video a couple times. So, law of cosine or cosine inverse doesn't have repeats. So if I'm finding the largest angle, it'll give me the angle, right? Sine, remember, how do I know that sine of 37 degrees when I go to do the inverse? Sorry, let me finish this. Let me finish to get down here to the inverse. So I'm now finding the smallest angle, and I'm doing this for a reason. I'm going to multiply both sides by 3. I'm going to have this decimal value. I'm doing sine inverse. This is for the smallest angle. Well, if you think about a triangle, there's only one angle that could be greater than 90. And that would be the angle opposite the largest side. Okay. So if I'm doing the largest side with cosine, it's going to give me the value because cosine doesn't have that repeat issue. Sine does, that repeat issue. If I do sine inverse of something, I don't know if it's I don't know if it's in certain situations. I don't know if it's opposite the largest side because I don't know all three sides, right? That's the side-side angle issue. But if I know all three sides, like I just found out, so I have 3, almost 5, and 7. If I pick the smallest angle, then there's no way that one's greater than 90. Okay, so I don't know. B could be greater than 90. So because that is the longest side. So I'm avoiding using law of sines on the longest side, and I'm actively trying to use law of cosines on the longest side. Because law of cosines doesn't have that ambiguous thing, and it will tell you what the angle is because it doesn't have that repeat issue. Law of sines has that repeat issue, but if I use it on what I know is the smallest angle, then I won't have to worry about it being that is this 21.4 or 180 minus 21.4. I don't have to worry about that because I know this is the smallest angle, and it can't be greater than 90. So that is why I chose to find A, the smallest side, so I don't have to worry about sine inverse giving me angle bigger than 90. Of course, B is the easy one. You just subtract those two. And again, you can, when you're doing law of cosines, use approximated values. I tell you to try to avoid it when possible, but just make sure you use the answer button on your calculator when you're doing these values. Even though you're writing in one decimal place, you're going to continue to use answer over and over again. But these are situations where it's unavoidable. There's some problems there, but I'll post those on the Google Classroom. So hopefully that made sense. Might still be a little confusing. If so, let me know. So here's an example 3 in a word problem. A farmer has a triangular field with sides 120, 170, and 22 yards. Find the area of the field. Then find the number of acres. Well, that last part's just busy work. We need to find an angle to an angle measure to use the area formula. So we want to find the area given 3 sides of a triangle. Okay. And sorry. Oh, okay. Right. Going back to the sorry, I was struggling with why do we need an angle? Okay, so if we want to use this area formula that we were given earlier in this chapter, we need an angle, right? So let's go through this. Let's find angle C. Why angle C? It's across from the largest or the longest side. Angle C is opposite the longest side. So that's why I'm choosing to do that. At law of cosines, we want to use it across from the longest side. Law of sines, we do not. Okay, so I'm plugging in 220. I'm plugging in 120 for A, 170 for B. I just chose these letters, by the way, A, B, and C. So if you were doing this problem, you could have made B 120, 220, or whatever, but it doesn't matter. In the end, you should get the same answer. Okay, so I'm plugging in for, then there's 2 times, and then A, B, and angle C is what I'm looking for. So 220 squared, 120 squared, 170 squared, that multiplied together. Add those 2 together. Subtract 4. Please don't add these 2. Subtract 4, 3300. You get 51 with all big numbers here. Divide both sides by that. You get 1/8. Negative 1/8 equals cosine C. So we're going to do cosine inverse of negative 1/8 and get 97.2 degrees. Okay, so now that we have an angle, we can use the K formula that's 1/2 A times B times sine of C. Okay, plug that in. We have our A and B from before, same A and B's. Sine of C we plug in and we get 10,120 yards squared. Then if you take that and divide that by 4840, then you could find out how many acres it is. So hopefully that made sense. Find the area of the figure. What? Well, quadrilaterals can be divided into 2 triangles. So that's what I'm going to do here. I'm going to take these two triangles and divide them, or this quadrilateral, and divide it into two triangles. I think we had a problem like this earlier. Was that this class? I can't remember. So I have K1 and K2. That might have been another class. I'm going to label the dividing line X. I'm going to divide this 130 into two angles Y and Z. We know everything else, I believe. Yeah, so we can actually find, so in order to find the area of K1, we have what we need, because we need two sides and an angle in between to use this area formula, right? Two sides and the angle in between. So we can find the area of K1. It would be 14, 12, and sine of 110. That would be K1. We would have issues finding the area of K2, though, because we know this side here, and that's about it, right? So let's actually find the area of K1 first, and then we can get to that. Area of K2. So there's a couple things we need to do. So we need more information. If you just take K2 and move it off, what we know is this side is 8, and that Z is less than 130, right? I mean, we can assume that it's not 1 degree less, but we don't know what value it is. We can find X, though, because it's part of this K1 triangle. And we can use law of cosines to find X. Okay, X squared will be equal to this squared plus this squared times 2 times this times cosine of 110. So add, we blah, 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 do all that, square them, add these together, evaluate all this times this, and then you get 21.3 is the distance for X, okay? To find, so now once we have all three of these sides, we have X is opposite 110, and we can find Y using law of sines, because we have 14 is opposite of Y, we have the value we just found is opposite of 110, so we can use the law of sines to find Y, and when Z will be 130 minus whatever Y is, and then we will have a side angle side to find the area of K. Okay, so 110 over what we just found is equal to what we're looking for, opposite of 14, multiply 14 by both sides, sine of 110, evaluate that in your calculator, do sine inverse. We get 38.1. Now, how do we know that's not 180 minus 38.1? Well, 141.9 is greater than 130, so it can't be that value. So that's how we know. So finding Z will be 180 minus 130 minus 38.1, which is 91.9. Whew. So now that we have those values, we have this value, we have this value. This is the 21.3. This is 91.9 and 8. We can now find the area of K2 using those three pieces of information. Oops, I just went down a little too far. 1/2 times 21.3 times 8, sine of 91. This is all a bunch of approximated values. Let me go back 1 second. So if I'm putting these in my calculators, as if I have multiple calculators. Okay, so let me move this over a little so I can see. So I had 196. I'm up here now. I'm just getting to the point where I had to approximate because I want to recap something here. Cosine. Everything that I plugged in right here in this calculator was exact values. And at this point is where I approximated. I'm going to then store this in alpha x. Okay, that's stored in x. And then I'm doing this down here. I'm actually using that approximated value here, right? So I want to make sure that I do on my calculator, despite the fact I'm saying this over and over again, despite the fact that I wrote 21.3, I need to take the square root of that, sorry. 1 second. Let me do second square root of alpha x. That's the one I want. And I'm now going to store that in x, alpha x. I'm overwriting the 454. And now x is 21.1. I can double check that by just writing x, seeing what it gives me. Okay, so now I want to make sure. That would have been a disaster here if I didn't notice that. So I want to do 14 times sine of 110 divided by alpha x, and I'm going to get the decimal value here that I want to do second sine inverse of second answer. Now this is what I'm doing right here. Hopefully everybody's following me. I get 31.8. I'm going to do store alpha y. Okay, so now x is this and y is this. I'm choosing those letters based on the problem. Okay, so then I also have z, so I'm going to do 130 minus alpha y and get 91.9, and that's going to be stored. I'm going to store that in alpha z. Okay, so now I have x, y, and z with values, rounded values, and I can then, when I go to find the area, and this is the reason I wanted to show you this, I can do 1/2 times, and then 21 was my x. Was it my x? Yes, 21 was my x. So alpha x times, what was I? 8, because 8 was the number that was on the figure given, and then sine of alpha z. Okay, this is what you should do even though you're writing 0.9. This is storing much more, and I want you to use the much more, okay, to get 85.2. Okay, then you just add K1 and K2 together to get the total area of that figure. Ooh, that's crazy. Crazy. And that's a wrap. Law of sine, law of cosine. Good stuff. Alright, so hopefully that was clear enough. We will have, work packets and stuff to do with these and bookwork. They are pretty long, so it's not a whole lot of problems. I think it's like 4 problems. Looks like it's 4 problems. Not showing you too much work there. But hopefully, oh, actually, I see that there's more problems here I don't have written up, so I'll have to look into that. But you'll see it on the announcement, what's assigned and what's due. Don't go by what I flashed there for a second. So, yeah, it's been fun. Thank you, and good day.